All right, guys. So in this next video, we're going to continue the trend of the nitrogen-containing group and talk about the nitro group. And the nitro group is an NO2. All right. So again, in the infrared spectrum, we can see a compound if it has a nitro functional group on it. And these are pretty easy, honestly. The way that I remember these is it's NO2, so therefore it should have two signals. And these two signals are what we would call a symmetrical stretch. And a symmetrical stretch is going to happen in the area of around 1600, and then the other one is going to be around 1400. Give or take a little bit. Again, there's wiggle room that is associated here. But these are symmetrical dips in the infrared spectrum at around 16 and around 14. So what I would see in the infrared, here is, let's say, 1600. Here is going to be 1400. I would maybe see a lot of busyness here in the beginning, but I would at least see a dip that happens at 1600 and it kind of comes back up, and then another dip that happens at 1400 and it will come back up. And these are symmetrical for the most part. That means they come down to about the same length when they do happen. And these peaks are very strong, which means they do typically tend to go all the way to the bottom when they can, and they are very narrow. They are not broad peaks like an OH would be or carboxylic acid would be. Okay, so with the nitrile group, if I take a look at some of the infrared spectrum, well, these things are, again, sometimes very easy to pick out if you know what these are supposed to represent. So here's around 16, here's around 14, and I see a peak that happens here, and I see a peak that happens there. And they're about the same distance down on the spectrum, which probably means that this is a nitro group. Again, two peaks, NO2. NO2 has two oxygens, so therefore two peaks. If you want to keep that in mind, then that might can help you with the NO2 group. All right. So this is ethyl nitrobenzene, the ortho position of ethyl nitrobenzene, and that's what we look at here. These two double dips that happen at around those locations. Here's another infrared. This infrared is nitrobenzene, and nitrobenzene again around 1600 and around 1400, give or take a little bit. I see a big dip that comes, and then another big dip that comes down as well, and they're about the same length on the infrared spectrum. Okay, so there's the clue that this thing is a nitro-containing group, and I probably have that type of compound on my hands. All right, so uh, here is another example. This is meta nitrotoluene, and meta means it's not the next door neighbor, but the neighbor down from them. And I see around a 16 and around a 1400 peak. And I see one that dips, comes back up, dips down again, comes back up. They're about the same length. And because there's two of them, that is the presence of a nitro group. Now, in the PowerPoint, there is a mistake, and maybe it will be fixed by the time that you get it, but you're probably seeing this basically on the screen now. It says up here at the very top, it's nitrile, and it's not a nitrile, it's a nitro. The same thing happens here. Up here at the top, it says nitrile, but it's not. It's a nitro group. And then again here, it says nitrile, but it's not. It's a nitro group. So these are all nitro groups that we're looking at, and that's kind of the symbolic area that you'll find them in the infrared spectrum itself. Okay, so in the next video, we'll go on to our next functional group. Now that we're talking about double dips that are happening about the same time, we can go on and talk about anhydrides. And an anhydride is part of the carbonyl family. But I think it works in a little bit smoother here because we're just now finishing up nitros, which have a double peak, and you'll see something very similar with the anhydride family as well.